measures of location and spread for grouped data. So here is our group data, and we use the interpolation formula for all of our calculations so far. But can we replace the formula with the calculator's built-in statistical functions? So in the calculator, what do you enter into this column? Yeah, that's the data column, and our data is in class intervals. You cannot enter class intervals into the calculator. What you can enter are class midpoints, but as soon as you put in midpoints, you've lost all information about the actual intervals and their boundaries and so on. And we need the class intervals to do any calculations for interpolation. So the simple answer here is you cannot replace the interpolation formula with any inbuilt function in the calculator. The midpoints here would be perfectly fine in the calculation of mean and standard deviation for group data, but if you're entering midpoints, you cannot do any calculations for interpolation. So you have to use the interpolation formula. In the interpolation formula, all of these values are straightforward except the frequency into the class. So I'm going to explain this a little more. So let's say if I want the 45th data value from this grouped frequency table. So starting at the beginning of my data, and your data is in order of size. So I've gone past 18 values, I've gone past another 20 values, so looking at cumulative frequency below, that's 38 values so far. I want to get to the 45th data value, so I need a further 7 values from this particular class interval to get to my 45th data value. So 38 plus a further 7 will get me to the 45th data value, which means the frequency into the class is 7. This time I want the 52nd data value. Again, starting from the beginning, that's 18 values so far. That's another 20, that takes me up to 38 altogether. Again, we can use the cumulative frequency to help. And I need another 14 to get to the 52nd data value. So this time my frequency into the class will be 14. And now we're looking for the 58th data value. So again, starting from the beginning, that's 18 values plus another 20, that's 38, we're still not there, plus another 14. I'm now at the 52nd data value, so my 58th value will be in the final class interval. So if I've reached the 52nd data value so far, I need 6 more to get to the 58th value. So this time I'm going 6 values into my class interval here, so the frequency into the class will be 6. So one thing I've not explained so far is that the method I'm using for interpolation is different to the one that's used in the textbook. So if you turn to page 26 in the textbook, example 5, so you can read the context, you'll see this calculation, and this is an alternative version of doing interpolation, and this is also a good method. So simplifying the numbers, and I'm not going to go into where the numbers came from, we've got this, multiplying by 3 on both sides, adding 33.5 to both sides, so now we have this. And all along what we were after was this Q3 data value. And if you compare the layout or the structure of the equation here, it's the same as the interpolation formula that I've been using. And if you're looking at the textbook example, you'll see that the lower class boundary is 33.5. The frequency into the class was 25.5, the frequency off the class is 30, and the class width is 3. So it's your choice. You can learn this method, the textbook method, but I'm not going to explain it here. I always use this interpolation formula. For practice, try these questions from these 3 exercises.